Assalamualaikum warahmatullahi wabarakatuh. Today I want to explain about pressure in pipe for subject fluid mechanics. Before we start, let me introduce myself. My name is Muhammad Tarmizi bin Yusuf. This is my group members. In this experiment, we need to test two situations: straight line water hose configuration and closed loop water hose configuration. From this straight line and closed loop, we need to calculate for pressure and velocity in this case. Formula involve such as volumetric flow rate to find the volumetric and the Bernoulli equation for find the pressure. From the experiment, we can to perform experimental and simulation flow exercise in the hose pipe to analyze pressure variation in hose pipe over a specific pipe length with two different configurations and inlet and outlet pressure using simulation, inlet velocity using simulation, density and viscosity of water using simulation, and Reynolds number using simulation. This is a picture how we set up for pipe for experiment closed loop, and this picture for straight line. These are my group members.
Assalamualaikum. My name is Mujahid bin Amran. Metric number B0921101179. Today I want to present about data for calculation maximum pressure in pipe. So this is the data. Density water is 1000 kg per meter cube. Density atmosphere is 1001.325 kilo Pascal. Diameter hose is 16 mm. Maximum height water of jet is 95 cm. Time taken to fill 200 ml is 19.09. Volume is 1 multiply with 10 power of negative 4 meter cube. The area is pi r power of 2. The radius is 8 meter and the answer is the 2.011 multiply 10 power of negative 4 meter square. The calculation for flow rate, the formula volume divide time. So the answer is the 5.238 multiply with 10 power of negative 6 meter cube. The velocity is the flow rate divide area. So the answer is the 0.026 meter per second. So the maximum pressure is for P1. The formula is P1 divide with density and then multiply with gravity, then plus V1 power of 2 divide with 2G, 2 gravity, plus Z1 equal to P2 divide with density and then multiply with gravity, then plus with V2 power of 2 divide with 2 gravity plus Z2. Since V1 equal to V2, so after we insert the value and the answer for P1 is 101.318 kilopascal. So that's all for me. Thank you.
Hi and Assalamualaikum. My name is Aida Basira binti Muhammad Talib and my matrix number is B0921104443. Next, I will explain more about the calculation for flow rate and velocity each hole for straight line. The diameter of the hole is 0.75 cm. The radius is 0.00375 meter. The area is 4.418 times 10 to the power of negative 5 meter square. The volume is 1 times 10 to the power of negative 4 meter cube. and then we have to calculate the flow rate and the velocity. So the formula for flow rate is velocity divided by times, and the formula for velocity is flow rate divided by area. So for the whole one, the time taken was 3 seconds. So the flow rate is 3.333 times 10 to the power of negative 5 meter cube per second. And then the velocity is 0.754 meter per second. Next, for the whole tour, the time taken was 5 seconds and 66 milliseconds. And the flow rate is 1.767 times 10 to the power of negative 5 meter cube per second. And the velocity is 0.400 meter per square. Meter per second, sorry. For whole 3, the time taken was 1 second and 16 milliseconds. So the flow rate is 8.621 times 10 to the power of negative 5, and then we get the velocity is 0.195. For whole 4, the time taken was 1 second and 82 milliseconds. So the flow rate is 5.495 times 10 to the power of negative 5, and then the velocity is 1.244 meter per second. And lastly, for whole 5, the time taken was 1 second and 74 milliseconds. So the flow rate is 5.747 times 10 to the power of negative 5 meter cube per second, and then the velocity is 1.301 meter per second. Okay, next, to calculate the flow rate and velocity each hole for closed loop. The data for diameter hole, radius, area, and volume is the same as the straight line. So, the time taken for hole 1 is 2 seconds and 10 milliseconds. So, the flow rate is 4.7619 times 10 to the power of negative 5 meter cube per second. And then the velocity is 1.0778 meter per second. For the whole 2, the time taken was 2 seconds and 27 milliseconds. The flow rate is 4.4053 times 10 to the power of negative 5, and the velocity is 0.9971 meter per second. For the whole 3, the time taken was 3 seconds and 55 milliseconds. The flow rate is 2.8169 times 10 to the power of negative 5, and then the velocity was 0.6376 meter per second. For the whole 4, the time taken was 2 seconds and 4 milliseconds. For the flow rate, the flow rate is 4.9020 times 10 to the power of negative 5, and the velocity is 1.1095. And lastly, for the whole 5, the time taken was 2 seconds and 7 milliseconds. The flow rate is 4.8309 times 10 to the power of negative 5 meter cube per second, and the velocity is 1.0935 meter per second. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zakwan bin Jaafar. My metric number B092110238X. Next, for the simulation, the total pressure closed loop in the start until the point position at negative 0.8, the total pressure is increasing, and after the middle negative 0.8 at the position, the total pressure is constant. Next, for the total pressure straight line, the point of the inlet is 0 exponent positive 0, and for the outlet is 1 exponent positive 5. So we can see the different of point for inlet and outlet for the total pressure straight line. Next, for the velocity closed loop, the position has 4 for inlet at the negative 1.3, and the three another is outlet at negative 0.x, negative 0.3, and the last one at 0. So you can see the velocity for the inlet is 0 exponent 0 until 1 exponent negative 1 for inlet, and for outlet from 0 exponent positive 0 until the maximum point of outlet at 9 exponent negative 1. Next, for the velocity straight line, you can see the y velocity, and for the inlet as the position from negative 0.008 until 0.008, negative until positive. So the point of outlet is biggest than the inlet. The point of outlet is scattered at the middle, and for inlet is scattered at left and right of the graph. Next, for the density closed loop, you can see for the inlet, the density is increased from 9.98 positive 2, and for the outlet, it has a 3 position. So for the density straight line, the outlet point is scattered at the middle, and for inlet point is scattered at the left and the right. The density for the outlet and inlet is, we assume, at the 9.98 positive 2. Next, for the viscosity closed loop, it has a 3 point for the inlet and outlet, and for the inlet has 1 position, and for the outlet has 3 position. So the molecular viscosity is around at 1 exponent negative 3, and the position is still same for the density and velocity. Okay, next.
Assalamualaikum, my name is Nur Baca Syaibani binti Jamsul Farizal, and my metric number is B0921104444, and I'm going to talk about the discussion for the assignment fluid. The data from the experiment and the simulation are nearly same when the same pressure and velocity finds are utilized in both simulation and calculation. According to the experiment result and simulation using ANSYS 2022, this experiment revealed the difference between closed loop and straight line hose configurations when the source pressure is the same for both configurations, but according to our findings, both configurations flow rates are different because the straight line uses one flow line, while the closed loop divides into 2 for the experiment, which result in a different flow rate in our calculations and simulations. Since each hole in the 2 configurations has a different velocity, the results for the different configurations, closed loop and straight line, are demonstrated to have an impact on velocity. Contrary to a closed loop, a straight line didn't provide an equal flow through each hole. As was observed, the water flow through each hole in a closed loop was nearly identical to one another. As a result, the closed loop's water distribution is greater than that of a straight line. Finally, conclusion. From this experiment, our group was able to complete the task given by the assignment, which was to calculate the pressure, velocity, and flow rate by hand and also by using an analysis simulation tool, Analysis 2022, to do a simulation for comparison of the manual calculation and simulation data to determine that both have the same outcome for the different configurations, straight line and closed loop. Thank you. That's all for me.